Okay, so the lesson that I would choose to teach about for this assignment would be about Hospitalis rule. And so these are kind of the notes that I would use in order to teach what Hospitalis rule is and how to compute the limit based on that. Okay, so the objective is to find the limit of an undetermined form using this rule. Okay, what we want to first define is what an indeterminate form is. Okay, which means that it's going to be when you have like 0 divided by 0, because when you have 0 divided by 0, it's not 0, it's undefined, because you have nothing divided by nothing, which goes into exactly nothing. Okay, so it basically says in an indeterminate form, if a function f of x and g of x are both 0 at x equals a value of a, then the limit as x approaches a of f of x over g of x cannot be found by just substituting in whatever the value of a is for x. Okay, what I would say more specifically is this. I would say, like, if you get, okay, f of x equals 0, and that's the keyword, g of x equals 0, then we're going to be using this rule that's below. Okay. So once I define what that undeterminate form is, we can then introduce the idea of Hospitalis rule, which is, I call it a stronger form, but it's basically like a way to figure out the limit without having to necessarily graph it. Okay, so again, this is what I would say above. If f of a and g of a equals 0, and f of x and g of x are differentiable on the open interval, and that g prime of x does not equal 0, and if x does not equal a, then what we can do is we can take whatever that limit is, and we can take, these are primes, okay? We can take the derivative of just the top and the bottom part, okay? Okay, but the biggest thing is, I would say to my students, you have to first establish that you have 0 over 0 in order to use this rule. Okay, so I would do a couple examples based upon this. So it says find the limit using Hospitalis rule. I would start off with, okay, if I plug in 0 for x, on the top I would just get sine of 0 over 0. Well, sine of 0 is just 0, and then you get over 0. So that's enough to determine we can use Hospitalis rule. So in other words, what I would do is take the derivative from there, okay? And so what I would do is the derivative of just the top would be using chain rule. So taking the derivative, you would have 5 cosine of 5x, okay? And then on the bottom, you would just have it derivative of x is just 1. Okay. So then from there, I can take 0 and plug it in for every x I see. And so I would get 5 cosine, that would just be 0 over 1. Cosine of 0 is just 1, so it's really 5 times 1 over 1. And so your final answer would be 5, and that would be your limit as x approaches 0. Okay. I would show one that deals with either quadratics or cubic functions. So with that, I would first plug in 2 and make sure I get 0 over 0. Well, in this case, when I plug in 2 in the top, I get really, it's 2 squared is 4, minus that would be 8, and then plus 4, so it would be 2 minus 8 plus 4. In this case, I would get actually just on that top, I'm going to write it below, I would get negative 6 plus 4 is negative 2. And then on the bottom, I would do 2 cubed is going to be 8 minus 12 times 2 is 24 plus 16. So then from there, I would say, okay, 8 minus 24 is going to be negative 16 plus 16 is 0. You cannot use Hospitalis rule for this. So in other words, you would have to find a different method. And I would ask my students to find that different method based on that. Okay. So I would have them do a couple more examples. One with, like, when we had trig identities, how would that look if we had that? Well, in this case, I would say, well, look at cosine of x. Cosine squared of x is the same thing as this. It's 1 minus sine squared of x, okay, which can be broken down to 1 plus sine of x. You just factor it, times 1 minus sine of x. Okay? And then on the bottom, here's how it helps. Is I have 1 plus sine of x times 1 minus sine of x. Oops. Okay. Over 1 minus sine of x. the sine of x's cancel out, so I'm just left with the limit as x approaches pi over 2 over 1 plus sine of x. You just plug it in, 1 plus sine of pi over 2, okay? Sine of pi over 2 is going to be root 2 over 2 plus 1. And so you get like that decimal form for whatever it would be, but you could leave it like that as well. Okay? And so you would not have to use Hopital's rule. So I would just emphasize to my students the fact that you're not using Hopital's rule for each one of these cases. You need to really make sure there's no other options before you do that. Okay? So I would kind of instruct my students to then, we would talk about another type of indeterminate form, which is when we have either positive plus or minus infinity over plus or minus infinity. So again, if we have this form where we have f of x over g of x is really plus or minus infinity over plus or minus infinity, okay, then you can use Hopital's rule. Okay, so you have to check for that as well. Okay, so if I'm looking at this, I'm looking at the limit as x approaches infinity of e of x over x squared. Well, here's the thing, is if I plug in e, it would be to the infinity over infinity squared. Okay, e to infinity goes up, it doesn't have any bounds, so it'd be positive infinity on top, and then infinity squared would also be positive infinity. So Hopital's rule does apply. So we would be able to just take the derivatives of top and bottom parts, okay? So doing that, okay, the derivative of top is e to the x, and then the derivative of the bottom is just 2x, okay? And again, we would still have infinity over infinity, okay? So again, we would have to apply Hopital's rule again, and so you would get x going to infinity, it'd still be e to the x, but then on the bottom it would be 2. So now plugging in x, you get infinity over 2. That's just infinity. And that would be it. Okay. So just emphasizing that rule again. Okay. So I would tell my students, doing the same thing here, I would have them try this problem. Okay. And then for the last type of indeterminate form, okay, that I would cover is when we have like an indeterminate form when it's 0 times infinity, we can always write it as a quotient. I would say these are more challenging problems, but you know, like I would, like, if I had time, I would do them as well, okay? But the main kind of points I would emphasize is the idea is if you have 0 over 0, like I would summarize it like this: 0 over 0 or infinity plus or minus infinity over plus or minus infinity, then Hopital's rule applies. What I would have them do as an assignment is probably like an assignment from their book in 8.2. This actually is used at my schools in AP Calculus BC. So I would have them do a couple practice problems in the book, and then just to test their understanding, I would probably have like one last like exit slip. So doing one problem with 0 over 0, one problem with infinity over infinity, and then finally have probably one more problem done when Hopital's rule does not apply, and just using the normal limits as per usual. But of course, there's a lot more rules with this. It's not just this. I would continue on if I had like a couple more days with all the types of indeterminate forms. And then finally at the bottom, I would say rate yourself just to make sure to see how well they are doing from 1 to 5, and then say what you can still work on, so it gives me that informal feedback that I would need to plan the next couple lessons for the couple of days. But yeah, that's kind of what my overall lesson would be. I think that it's well put together in the sense of it's very student data driven, and the students would be able to catch on, I believe, pretty quickly with their knowledge of derivatives.